A tiny speck appeared on July 1, 2025, flickering across the screens of Chile's Atlas telescope, hidden beneath the star-strewn skies of the Atacama Desert. Astronomers initially thought it was merely a different asteroid, but its trajectory soon revealed something extraordinary. For hours, the data showed an elliptical orbit screaming free of our sun's gravity at a speed of 58 kilometers per second from interstellar space. This rock was not a local one. It was the third confirmed cosmic wanderer ever detected, an interstellar object named 3I, Atlas. Its arrival sparked a worldwide commotion. Over 200 observatories, from NASA's James Webb Space Telescope to backyard amateurs, redirected their gaze. Why the urgency? This comet isn't just passing through. It's challenging everything we understand about chemistry, comets, and how planets and distant stellar nurseries are created. In this video, we will explore the mysteries of 3I ATLAS, its bizarre characteristics, and explain why it is changing the way we think about the cosmos. If you're as enthralled by the universe as I am, stay tuned. This is a story you won't want to miss. Setting the scene, think of our solar system as a commotion-filled cosmic highway with orbiting planets, asteroids, and comets in an orderly dance around the sun. Then, out of nowhere, 3I ATLAS slams into the scene, breaking all the rules. Its path is nearly flat, tilted just 5 to the ecliptic plane where Earth, Mars, and Jupiter orbit. Compare that to the first interstellar visitor, Oumuamua 2017, which dove in at a steep 33, or Borisov 2019, angled at 44. Those erratic entries are what you'd expect from wanderers roaming the galaxy. However, 3I ATLAS threads the needle. It passes by Mars at 0.19 astronomical units, approximately 28 million kilometers, on October 3, 2025. Venus at 0.65 astronomical units on November 3rd, and Jupiter's orbit at 0.36 astronomical units by March 16th. Its closest approach to the Sun perihelion occurs on October 29th at 1.36 astronomical units, safely beyond Earth's orbit. This alignment is no coincidence. It's a statistical rarity, giving scientists multiple perspectives to examine it. Imagine a rare bird flying through your backyard. Telescopes, cameras, and binoculars are trained from every angle. That's what's happening right now. Why 3I Atlas stands out. Its chemistry truly sets it apart, rewriting textbooks and turning heads. When the James Webb Space Telescope turned its golden mirrors toward it on August 6th, it revealed a coma, a glowing cloud of gas and dust dominated by carbon dioxide CO. The ratio of CO to water was approximately 8:1, meaning nearly 89% CO among major volatiles. Typical comets in our solar system are water-heavy, with CO as a minor component. Borisov, for example, was rich in water and exhaled familiar gases like hydrogen cyanide and carbon monoxide. But 3I ATLAS is mostly dry ice. Initial data from JWST showed it releasing 129 kilograms of CO per second and only 6.6 kilograms per second of water, even at 4.5 astronomical units, well beyond Jupiter's orbit. By late August, the Swift Observatory detected hydroxyl gas, a sign of water breakdown under sunlight, rising to 40 kilograms per second near 2.9 astronomical units. This suggests deeper water ice layers began vaporizing as the comet warmed. Such a layered structure implies it formed far from its parent star, in a cold zone where solid CO could freeze perhaps billions of years ago, in a different stellar. Strange chemistry and unanswered questions. The surprises didn't stop there. The extremely large telescope in Chile, observing the comet's coma in July, detected strong nickel vapor emissions but very little iron. Every other comet we've studied, from Halley to Borisov, shows nickel and iron together, forged in supernovae and sublimating at similar temperatures. This decoupling is almost unheard of in nature. One theory suggests a carbon monoxide-rich environment could cause nickel to form compounds while iron remains behind, but such conditions are rare. On Earth, we separate nickel from iron through industrial methods like the Mott process for nickel carbonyl. No one's suggesting the comet was made in a factory, but the analogy is unsettling and demands more study. 3.1. ATLAS is also depleted in carbon chain molecules like C and C, which usually give comets their vibrant glow. Yet, during the lunar eclipse on September 7, 2025, it likely displayed a striking green coma produced by rare emitters such as cyanide, not the usual carbon chains. It's a cosmic puzzle one whose pieces don't quite fit our expectations. Size is yet another headache. Early brightness measurements suggested a giant nucleus up to 20 kilometers wide, in contrast to Oumuamua's to 100 meters or Borisov's 1 mile. However, Hubble's July 21st images, combined with non-gravitational acceleration data, brought it down to 0.32 to 5.6 kilometers, probably less than 1 kilometer, with a bright coma making it appear larger. It's roughly 15 meters per day of low acceleration squared indicates a huge, dense core-resisting gas jet pushes. Unlike Oumuamua, whose mysterious speed increase was puzzling, ATLAS's coma was active early at 6 astronomical units in May with a sunward dust plume of micrometer-sized grains defying the typical tail that the solar wind pushes away. The VLT's polarimetry revealed a negative polarization, pointing to a surface of icy grains mixed with dark organic tholins like those found on distant Kuiper Belt objects. It rotates once every 16 hours, as shown by light curves displaying a steady brightening to magnitude 14 by September, peaking at 11.5 near perihelion, bright enough for amateur scopes under a pitch-black sky. The global mobilization for 3I Atlas has been a masterclass in collaboration. Over 200 observatories, from Pan-STARRS in Hawaii to Gemini South in Chile, have contributed thousands of measurements. Hubble and JWST from NASA reshaped their plans for high-resolution studies. Spherix, on the other hand, mapped a 348,000 kmco coma. On October 3rd, Mars orbiters like NASA's Mars Reconnaissance Orbiter MRON ESAS ExoMars Trace Gas Orbiter captured 28 million images, potentially resolving the nucleus. ESAS JUICE spacecraft en route to Jupiter plans November observations with its spectrometers. Amateur astronomers are contributing through astrometry and upcoming occultations events where the comet blocks background stars to better define its shape. There's even speculation about a chance encounter. NASA's Juno probe orbiting Jupiter could, in theory, intercept 3I Atlas if redirected in mid-November 2025 or March 2026. Across tens of millions of miles, Juno's UV and infrared instruments could study gas and dust, but fuel limits and risk make this unlikely. Still, talk continues of a dedicated interstellar intercept mission, perhaps a 200 kg spacecraft ready for rapid launch on brief notice. False beliefs have swirled, particularly after early speculation about artificial origins. Avi Loeb's Teams RRIV paper July 2025 noted the initial lack of outgassing, flat trajectory, and size as possible evidence of alien engineering, echoing Oumuamua discussions. However, the data tell a different story. JWST and Swift confirmed activity consistent with classic cometary behavior, dust plumes, gas jets, and no radio signals, despite scans from FAST and Green Bank telescopes. The trajectory aligns with galactic disk dynamics, and the nickel-iron ratio fits unusual but natural chemical models. It's not alien technology, it's an alien comet, formed in a stellar nursery unlike our own, anywhere from 3 to 14 billion years ago. The lesson: extraordinary claims require hard evidence. 3.1. ATLAS instead delivers natural wonders. If you're enjoying this cosmic detective work, click share and like, and leave your thoughts below. What's the weirdest comet trait you've heard of? Why does 3-eyed Atlas matter? It's a time capsule from another star, carrying clues about planet formation across varied environments. Its CO dominance suggests exoplanet systems with distinct atmospheres. Insights from its dust-informed spacecraft design, shielding, and even future comet mining for fuel or water. The rapid global response highlights skills critical for planetary defense against rogue comets. With the Vera C. Rubin Observatory launching in 2026, we may soon identify dozens of interstellar objects yearly, making such campaigns routine. The unknown shrinks with every visitor, teaching us what's possible in nature. As 3i, Atlas swings past the sun and vanishes into the galaxy's void, it leaves us with a richer view of the cosmos. Its odd chemistry reminds us of our smallness, yet also of how far curiosity can reach. What's next? A new interstellar guest, perhaps. Stranger visitors may yet await. Subscribe for updates and share this with your fellow space nerds.